Alright, so the answers to your homework are posted, and I'll go over some of these, and hopefully it'll make a little bit more sense to you. Alright, so let's see here. 16 to 28 even, 16 to 24 even, they were all amplitude, period, and phase shift. So I'll make a little table here. Amplitude, period, and phase shift. Alright, we'll see if this works. Alright, so for number 16, problem says y is equal to 10 times the tangent of 4 theta. Now, theta is technically by itself. Right? We don't really have to factor something out. We only have to do it if it's plus or minus. So let's go through it. The amplitude, we're going to say none, because the only graphs with amplitude are sine and cosine. Period would be the normal period of tangent, divided by 4, which in this case would be 45 degrees. And we're not adding or subtracting anything, so the phase shift is 0. Let's move to the next one, 18. 18 says y is equal to 2 times the sine of theta. Theta is by itself, so this one's pretty easy. The amplitude would be 2. Period is the normal period of sine divided by the number in front, 360. And the phase shift, we're not going left to right, so we could say 0. For number 20, it says y is equal to 4 times the sine of theta over 2. We talked about whenever you're dividing by 2, that was a class example. We said that that's really just 1/2 in front. There's no plus or minus, so the way that we do this is the amplitude would be 4. The period is the normal period of sine divided by 1/2, which is 720. And then the phase shift, we're not going left to right, so that would be 0. For number 22, looks like we have radians. So let's talk about how to handle this. Just as kind of a side note, whenever we see theta, this means degrees. Talked about this quite a few weeks ago, so in case you forgot, theta means we're in degrees. Whenever we see x, we just want to make sure everything is in radians. It's not a big deal, it's just like converting from inches to feet. So for number 22, it says y is equal to 12 times the cosine of 3 times x minus pi over 2. Alright, now the x is by itself, so there's nothing to factor out, so we'll just go through this. The amplitude would be 12. Now the period, we want to make sure we're in radians. So I had told you the normal period of cosine is 2 pi, or the normal period is 360. We're going to be dividing that by 3. So if you tell me the answer is 120, you just have to make sure you convert that back to radians. Or you could just keep it in radians. The normal period, instead of 360, if you use radians, 2 pi, we're just dividing by 3. So 120 converted to radians would just be 2 pi over 3. And then the phase shift would be pi over 2 units to the right. Alright, we'll do, say, number 24. 24, it says y, let me see here, what is it asking us to do? Here, let me get the book out real quick. Alright, so 22, we're on page 315. Alright, so 315, number 24. It says we have y is equal to 10 times the sine of 1/3 theta minus 300 degrees. Okay, so the 1/3's in front, it needs to come out. So we'll factor out 1/3. And 300 divided by 1/3 is 900. So we're in degrees. The amplitude is 10. The normal period of sine, we are in degrees, so that would be 360 divided by 1/3. And that would be 1080. And a phase shift would be 900 degrees to the right. All right, so that's how we do those kind of problems. And I asked you to do 26 and 28, so maybe I'll pick one of these here. 26 and 28, they're similar. I'll just do both, what the heck. Alright, so number 26. 26, it says we want to write a function with sine, and it says that the amplitude is 2/3. Period is pi, so we are in radians, and the phase shift is pi over 4. Okay, so I told you usually I'll tell you the direction and the number. So if it just says pi over 4, it's really just to the right. Okay, so if you got a little confused, it's not a big deal. That's what it means. So the way we're going to do this is we're going to fill in these blanks. Whenever we're in radians, we use an x. So if the amplitude is 2/3, we could put 2/3 here, or negative 2/3. It doesn't matter. Phase shift is pi over 4 to the right, so we're going to write minus pi over 4. If you are confused and you put a plus sign here, it's not a big deal. It doesn't matter. You know, on the test, I'll tell you write an equation that's to the right, pi over 4. And then for the period, well, we know it's usually the normal divided by whatever number's in front there, call it k. And in this case, it's telling us the period is pi. Well, the normal period in radians is 2 pi. So 2 pi divided by what is pi? We can multiply both sides by k, or cross multiply, and divide both sides by pi. We get k is equal to 2. Okay, I'll do the next one here, number 28, similar. Now 28, it says the amplitude is 1/2. The period is 3 pi over 2. And the phase shift is negative pi over 4, which really means pi over 4 to the left. So let's fill in the blanks. And the amplitude would be 1/2. Phase shift is to the left. It's plus pi over 4. Again, in the homework, if you were confused, it's not a big deal. On the test, I'll tell you which direction. And then we're going to put a k here, because we know that the normal period divided by k is going to equal 3 pi over 2. Well, the normal period of sine is 2 pi. So let's cross multiply, and let's figure out what k is. 2 pi times 2 is equal to 3 pi times k. So 4 pi is equal to 3 pi k. To get k by itself, we divide by 3 pi. And we would get k is equal to 4/3. How you do a problem like that. Alright, and let's see what I asked you to graph. For number 36, problem says y is equal to 3 times the sine of theta. So usually we find the amplitude, period, and phase shifts first. The amplitude would be 3, period is normal period of sine. There's no number in front, and the phase shift is none or 0. So if you go to graph this, I did ask you to graph from negative 360 to positive 360. Amplitude's 3. And the way I taught you to graph is you pick numbers, you can make a table. So like theta, and then 3 times the sine of theta. I'll choose negative, let's start at 0. Sine of 0 is 0, right? I mean, you could just type it into your calculator if you want, but 3 times the sine of 0 is still 0. If the period's 360, it'll be 0, 360 before and after. 3 times the sine of 90, you could store it in your calculator. Sine of 90 is 1, so 3 times that would be 3. It would be the same 360 before and 360 after. Sine of 180 is 0, so 3 times 0 is 0. So I kind of see what's happening here. Once you have a few points, you could start to figure it out. I'd imagine this is negative 3. I would imagine at 180 it's 0. I'd imagine at 270 it's negative 3. And that's what we get. That's what the answer would be. Okay, we'll do the rest here. Number 38. Number 38, it says y is equal to 4 times the sine of theta over 2, which we know is the same thing as 4 times the sine of 1/2 theta. So we'll write amplitude, period, and phase shift. The amplitude is 4. Period is 360 divided by 1/2, which is 720 degrees. And the phase shift is 0 degrees or none. So let's go ahead and graph these like we usually do. And again, you could type this into your calculator. We know the amplitude's 4, so it's going to go up to 4, down to negative 4. We can make a table if you want. And always use the original, so 4 times the sine of a divided by 2. So let's see what this looks like. I'm going to start at negative 360. I'll store negative 360. And I'm going to type in 4 times the sine, mem variable a divided by 2. And I'm getting 0. So 720, it'll be the same thing. Let's try to figure out negative 180. I'll skip around a little bit. Negative 180, I'll store it for a. And I'm getting negative 4. How about at 0? What happens at 0? Just kind of picking points here. I get 0 at 0. Alright, store to 180. I'm getting 4. And it looks like we have a graph here. It just looks like it's a little bit stretched out. And that's what it should be. The period's 720, it's twice as long. Alright, we'll do one more. Let's see, 40. For 40, it says y is equal to the cosine of theta plus 30 degrees. Alright, so the amplitude theta is by itself. The amplitude's 1. The period is normal period of cosine is 360. And the phase shift would be 30 degrees to the left. Just like the other ones, we'll set it up. 2, 3, 4. 1, 2, 3, 4. Make it a little table. And let's plug in some numbers here. Start at negative 360. So on my calculator, I'm going to type in the cosine of mem variable a plus 30. Making sure I'm in degree mode, I'm going to store negative 360. And my calculator is telling me it's 0.9. Almost 1, but a little less. Remember, it has to go up to 1 and down to -1. All right, let's store -180. Let's just see what that is. I'm getting -0.9. Okay, so I kind of have a feeling it's going to be 0.9, -0.9, 0.9, -0.9. Let's just double check. I'll plug in 0, and I'm getting 0.9, right? Okay, so my suspicions are correct. But this plus 30 means the graph went to the left 30. So normally the graph of cosine looks like this, right? So if the graph is going to the left 30, I would imagine instead of being at 1 right here, it would be moved this way to the left 30. So, and all these points are shifted a little bit over. Something like that. All right, and actually if we're going to the left 30, let's just see what's happening at -30 degrees. If I store -30, I do get 1. So you could see that, yes, the peak did get shifted to the left 1. Normal cosine would look like this. Something like that. It's a little tricky to draw. So you could see the actual graph was moved to 30 degrees to the left. We'll practice some more today. We're not doing anything new. All right, same old stuff. So thanks for watching. Stay tuned for day 2.